So when you're done taking data, hopefully you have some graphs that look like this. And they're pretty small and hard to see, so I'm going to go up here and click this auto scale button here on the top, little graph with the A in it. And that's going to take and it's going to make it fill up the screen on each one of those graphs. So you'll notice we have a distance versus time graph here on the top. We have a velocity versus time graph here, and we have an acceleration versus time graph here. Depending on, I had a little jerk thing happen here when the pulley went tight or something, so that kind of skewed my data a little bit. But we're not going to look at that. We're just going to look at the part where the weight is falling. You'll notice as something speeds up, so our cart speeded up, its velocity increased as it fell. That's going to make it fall further and further each second, so this distance versus time graph gets steeper. And the acceleration looks close to zero, but that's only because I have this weird jump here at the end. But to find acceleration, acceleration measures how fast velocity is changing. So if we look at our velocity versus time graph, if we find the slope of that, that tells us how fast the velocity is changing, the change in velocity, every second, which is acceleration. So to do that, I don't want this part here, because this is after my washer hit the ground, the cart stopped accelerating so much, and something weird happened, probably with the blower blowing the pulley or the string or something. But this here, you'll notice, is a nice straight line. So this is the part where the velocity was increasing at a constant rate, or was accelerating at a constant rate. So I'm going to start here in the upper right, and if I click and drag across, I'm going to highlight that whole straight section. And then from there, if I go up to the top, there's a couple ways you could get it to do the slope. But one way is to go up here to this kind of straight line, this straight black line on a curve. That's the linear fit button. If I press that, that gives me an equation. I'm going to pull that over a little bit. And it says that the equation is the velocity, the y value equals mx plus b. It's slope-intercept form. Y equals mx plus b. So velocity equals the slope times the time plus the y-intercept. So the slope right there, 0.1495 meters per second, that is my acceleration. So in my data table, I'm going to write 0.1495.